Let us look at Raabe's test. In ratio test, which we have seen previously, if the limit as n goes to infinity of the ratio u sub n plus 1 by u sub n is equal to 1, then we cannot say anything about the convergence of a series, because in that case, the test is inconclusive. To decide convergence, we must examine how fast the ratio approaches 1. If it is too slowly, it is approaching 1, then it will be divergent. If it is fast enough, it will be convergent. And at exactly the critical rate, it would again be inconclusive. Remember P series? Now, P series are the benchmark series against which we compare many other series. So let us look at them. In the sense, we take the P series and try to figure out how we can refine this ratio test so that we can figure out the convergence. Now, P series 1 by n to the power of P, we know, is divergent when P equal to 1. So when P equal to 1, remember, this is the harmonic series. And when P is greater than 1, it is convergent. For the general term, u sub n is equal to 1 by n to the power of P. When we take the ratio, we get u sub n plus 1 by u sub n equal to 1 by n plus 1 to the power of P divided by 1 by n to the power of P. When we convert this into a multiplication, n to the power of P goes up. So we have n to the power of P by n plus 1 to the power of P. P exponent is the same for both numerator and denominator, so we take it out. So we get n by n plus 1 to the power of P. Now, the thing is, we want to get it in the form of 1 plus 1 by n kind of thing. So how do we do that? What we'll do is, we will write it as n plus 1 by n to the power of minus p. So here we are inverting the base, and we are also taking the negative of the exponent. So that way what is happening is, we are taking the reciprocal twice, which changes its form, but the meaning remains the same. So that becomes 1 plus 1 by n to the power of minus p. Now we expand it. 1 plus 1 by n to the power of minus p, which gives us 1 minus p by n plus the big O. That is the rest of the terms of the expansion. Remember, this is nothing but u sub n plus 1 by u sub n is equal to 1 minus p by n plus the big O. Now, ratio test looks at multiplicative change. Remember, ratio test, implicitly we do a comparison with geometric series, which is basically common ratio keep getting multiplied. But convergence depends on the rate of decay of the terms. To extract this decay rate, we examine the reciprocal ratio. So we take the reciprocal of this u sub n plus 1 by u sub n, which gives us 1 plus p by n plus the big O. We take 1 to the other side, we get u sub n by u sub n plus 1 minus 1 equal to p by n plus the big O. Now, on the right hand side, if you notice that n is common to all the terms, so we take one n common out. Not only that, we can take that n, which we have taken it out of all the terms of this right hand side, and take it to the other side. We get n times u sub n by u sub n plus 1 minus 1 is equal to p plus the big O, starting from 1 by n instead of 1 by n square. Means now we can take the limit. When we take the limit, we get limit as n goes to infinity of n times u sub n by u sub n plus 1 minus 1 is equal to p. Why? Because all the rest of the terms have a n in the denominator, which means those terms will disappear. So we have found the limit of this expression equal to p. And remember, this is with respect to the p series. So if p is greater than 1, then the series converges. If p is less than 1, then series diverges. If p is equal to 1, then the test is inconclusive. So we have refined this ratio test into a form which allows us to overcome the inconclusiveness of the ratio test. Here, what are we trying to figure out? Is the rate of change of the ratio as it approaches 1 in the limit. Now let's write it in the form of a theorem. Let the series u sub n be a series of positive terms and limit as n goes to infinity of n times u sub n by u sub n plus 1 minus 1 is equal to L. Then if L is less than 1, the series is divergent. If L is greater than 1, the series is convergent. And if L is equal to 1, then the test is inconclusive. Okay, that was a theorem, a formal definition. But let's see, briefly what is actually happening. So given a series U sub n, we take the ratio of consecutive terms, U sub n by U sub n plus 1. We subtract 1 to measure how far this ratio is from 1. So if the ratio is 1, remember, it means there is no change in successive terms. So when we subtract 1, we measure how far this ratio is from 1. Then we multiply by n to zoom in on this small difference. And then we let n go to infinity. So ratio test looks at the ratio directly as is. That is, you can say it is 1x zoom. Whereas Raabe's test looks at the deviation of the ratio from 1 with nx zoom. So when ratio test sees the ratio flattening out at 1, Raabe's test zooms in to reveal how it changes. So Raabe's test is like a magnifying glass. Okay, so I think Raabe's test is clear. Now, if you found this session helpful, please do like, share, and subscribe. Comments, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.